This is part 2 of a series of 3 videos that are designed for uh, practicing analysis, visualization, and data cleaning skills that you have probably learned at least the basics of in a previous tutorial, but here we'll get into it a little bit more, give you some different examples, things like that. So this is part 2. Remember that you should have a folder called building permits, and inside that folder you should find the original data file, the original RMD file, and also an HTML file that got created automatically when we saved the file at the end of video 1. And then there's also the .rproj file and some user files and history files that come with the project, and they're just default created. You can now reopen that project a couple ways. One is you could double click on our PROJ file right here, or you can go into R. There's a couple ways in RStudio to get to it. One would be the file menu, open project. There's also a recent project, which is where you'll find it. And then the other thing, this is the place I like, is in the upper right-hand corner of RStudio. There's project, and you can see all the various projects that you've worked on recently, and you can quickly open them up. So you can use one of those 3 techniques to open your project. And once you do, the files menu in the lower right section will show you the various files that you have. Sometimes it might automatically open your RMD file, but if it didn't, go to the lower right corner and open that permits notebook. So we're going to pick up where it says part 2. However, when you have closed a file, it deletes your data is gone. That data file, we're using a data frame called permits. It's not here anymore. You have to rerun all the code. And all these changes that we made in the first video, they're not actually permanent. We didn't change the original data file. We just changed the working file in R, and that working file in R disappears when you shut it down. So what you have to do is you have to rerun your chunks of code at the beginning of your file. And the easiest way to do, if you were doing your own project and you just needed to keep writing from wherever you left off, you could do run and choose run all chunks below, and it'll take you down to wherever you left off. However, since there is chunks below here that I wrote, what we're going to do is just go through and run each of the chunks that have some sort of change in them, or just to be safe, go ahead and run all the chunks. So you might want to just hit pause or try to follow along with me and run each of the chunks till you get back down to where it says part 2. These ones that are just running a little query, you don't necessarily need to run them because they're not changing and affecting that file we're working with, but you can run them if you need to. And you'll see some of them actually are still here. But like here, create a new column, we need to run that because we need to recreate that column. And then we should be at line 117, part 2. So in this part 2, let's start looking at the types of housing that is being built. Previously we were just kind of evaluating our data set, getting a sense of it. One of the things we didn't look at is what kind of data are they measuring in here. So if we run this chunk, we can see that they're counting up how many accessory dwelling units, duplexes, multifamily, single family, townhomes. However, we've got some potentially dirty data here where we've got duplex, and then we've got duplex, triplex, quad, multifamily, 3 units or more, multi-units, 5 units or more. So maybe we have another dirty data issue that we need to suss out a little bit. So let's add a little bit to this. Let's start by seeing if there's any consistency across time. Remember that this data goes back to 1970, and these kind of coding issues with calling it a duplex one year, calling it a duplex, triplex, quad another year is common in over time when an agency changes the way they track things. So this is the first place I would start. So let's run this query where we're going to group by 2 things. We're going to group by both year and housing type description. And then we're going to order it by that housing type description to see what happens. So we can see all the, it's going in alphabetical order, obviously. You can see in the early years it's called duplex. Oh, and then here, starting in the year 2000, it changes to duplex, triplex, quad. Maybe it's the year 2000. One thing we could do is in our range, we could add year as a secondary grouping sorting option. And so then we will get, you can see duplex is going 70, 71, 72, all the way through. There we can see definitely, yep, the year 2000, they started, instead of calling them duplexes, they started measuring duplex, triplex, quad. And then here's the multifamily one. In those early years, it was 3 units. And then somewhere in here, looks like also in the year 2000, they switched to 5 units or more. But it does look like there's some overlapping years where here's 2003, there's both a 3 units and a 5 units, but notice there's only 3 records for 5 units. So it looks like they phased this in possibly. It's something you'd probably want to look at a little more carefully. But one way we could see this pattern a little better would be to create more of a pivot table style table where the years are going down in the rows and these descriptions are going across the top, and then we're getting the count accordingly. And that's like a cross tabulation in, say, pivot tables in Excel. So the way to do that one way to do that in R is with a function from Tidyverse called pivot wider. So I'm going to show you a couple different ways to do this. Pivot wider likes very succinct data, like the way we've summarized it in this query that we just ran. It doesn't so much like the big table with everything in it, all the different columns, not completely summarized to the way you want. It likes a little bit cleaner. So I tend to find I have a little more luck getting my pivot wider to work better if I first group my data together the way I want. So you can see in line 145 here, this is the exact same query we just ran, only I'm going to assign it to a data frame. I'm just going to call it temp. This is just a temporary working file for a minute that we'll use. And so it's created a file that looks almost exactly the same as that query we just ran. But now this makes it easier for me to show you the syntax of pivot wider. Pivot wider wants you to give it first the name of the data frame that you're referring to, and then it wants you to say which column from that data frame should be the columns in your new output. And that's what names from means. It's a little confusing. I wish they would call it columns equals, but really what they want to know is what do you want to set as the names for these columns? And that's going to be these multifamily, duplex, single family, etc. And then it wants to know what do you want as values in your data, and that's going to be our count of units. So I'm just going to run this line here. You'll see that it's not those housing type descriptions are now the column names. And think of that's what the names from references. And each column, each row is a year. And so there's only one record for 1970, unlike what we had previously. These headers are a little cumbersome and problematic, so we could deal with that in the next section. But I also wanted to show you kind of a second way you could do that. Instead of making this temporary table, you can just bake that query right into the spot in your syntax that would be the name of the table that you want. So instead of just simply putting in the name of a table, you put in the query that you want, and then here's the names from again and the values from. I'm going to make one other change. We have a code in our data set called housing type that is an abbreviation for these single family, multifamily, etc. Then I'm also just going to tack on the clean names function like we did on the import to ensure we have some nice, neat, clean names. And again, and here I'm going to assign it to a data frame. And then down here's a way we can view our new table. And so it looks a little bit neater and cleaner. And we can also see that pattern, that switch in the early 2000s where they stopped using these two codes and started using some new codes. That's a lot more visible here. So one of the other things we might want to do is we don't have a column in here that gives us the total number of units each year. We might want to add together all these columns and have a total column. But in order to do the math, we'd have to deal with these NAs. There's some ways with coding where you can tell it to ignore the NAs. But the other thing you can do is convert these NAs to zeros just to make your life a little easier. And this little snippet of code right here with mutate all is going to look through your entire table, find any nulls or those NAs, and convert them to 0. And this is the exact piece of code you would use every time you wanted to use it to do this. And you just simply tack it on to your pipe it to your table. And then what we're going to do here is overwrite our existing table with this cleaned up version. So this is something you want to be cautious of. You want to make sure that there aren't NAs in your table that you want to keep for some reason. In this case, there's not, so we're good to go. All right, so let's add a total column. Here's a couple different ways you could do it. I'm giving you a base R version, and then I'm also giving you the tidyverse version using mutate. I tend to use the tidyverse version, but I wanted to show you the base R version because I do see this a lot more frequently, the syntax, a lot more frequently when I go online on Google to find help on something. I think a lot of people still use base R, and I find solutions to things often with base R code. And so in base R, you can tell it to create a new column simply by naming the table with a $sign and then the name of the new column you want to make, and then use the assignment operator. And then this is a function called apply that allows you to say, go in the table called permits by year and use columns 2 through 8 and sum them together. The comma on there is more important than you would think. If you wanted to reference the rows rather than the columns, you would put something before that comma. So in this case, what we're saying is the comma is essentially saying, hey, we're not working on the rows, we're going to work on the columns, and we're going to work on columns 2 through 8. And what it'll do is create a total column and put it in our table. So I'll run this and we'll open permits by year. And there it is, total, all filled in for every row. You might want to just double check that it got the right columns. And I, figured out that it was rows or columns 2 through 8 simply by, we have 9 columns and I want to ignore the first one, so 2 through 8. Now, for the other example, I want to create a column called percent single SFD for what percentage of all these units were this single family detached housing, SFD. So what percentage were single family detached for each year. So with the tidyverse, you overwrite your existing data frame with the assignment operator and the name of the data frame. Then you say, I want everything from the existing permits by year. And then mutate and add on a column called percent SFD. And the math here, this is straight up math, SFD, this SFD column divided by the total column. Lovely, just simple little percentage. So I'll run this chunk, and now we'll look at permits by year. There's a percentage. And it's always going to be in a decimal point unless you tell it otherwise by like multiplying by 100 or something like that. Okay, so now it's your turn. I want you to pause the video and try to do these couple little exercises. They're going to be very similar to what we just did with adding a new column and pivot wider, but just using a little bit different data set. So the first one is to create a column called middle and add together these 4 columns. You can use either the base R or the tidyverse approach, whichever one you want. And then the second one is to practice pivot wider. So this time you're going to go back to the permits table, our original table, and group by the city, new, and the year. Remember before we grouped by the housing type and the year, but so this time it's the city, new, and the year, so we can count up the total units in each city each year. And then your pivot will have city, new as the rows, and the year will be the columns this time. And when you're done, come back and we will go through the answers. So here's a couple options you could have done for that first question to create a column called middle. Here's the base R approach, where you create the column and then you say add together these 4 columns, literally just using a plus sign. There's probably about 5 other ways you could add these columns together. I like this, it's nice and clean, it's readable. If you remember when we did the, add together columns 2 through 8, that is not as readable. It's like, I don't understand, what are we adding together here? In this case, I know we're adding duplexes and townhomes and ADUs and triplexes. And here's the tidyverse way with mutate. Again, very, very similar. Pivot wider, again, you could do either option. The one where you create a separate data frame and then reference that data frame in your code. That I have down as option 2. Option 1 is to do it all right in the pivot wider. And you should get something like this where you have the years going across and 1 row for each city. And so you can, there's a lot of columns because we have a lot of years here. All right, so let's move on. We're going to move on to part 3 here in a minute. So like you did at the end of part 1, let's save this file and we're going to close out of everything and close out of your project, and then we will start it back up again at the beginning of part 3.